guys, my name is Amit Verma, as Charissa introduced, and I'll be taking this session. Mostly I'll talk about uh, natural language processing in industry, what kind of problems we face and how we solve it. And after that, I'll talk about little bit of how Python 3 is helping us overcome those problems and how easy it is to implement the natural language processing or process the language and do cool stuff in newer version of Python. So we'll see that. Okay, so let me share my screen and you guys can confirm if you can see my screen right now. Is it visible?
Yes, sir, it is.
So currently I'm working as a research scientist in a US-based startup, which is called CLM. So my area of expertise is in natural language processing, but currently in my company, I work on legal languages, not just natural language. So in my current company, I work on like streamlining the contract management process, where we try to leverage the AI possibilities, AI features in contract lifecycle management. And so there are various type of complexities that we face while we are processing the contracts or legal languages, and then we try to come up with efficient algorithms or machine learning or AI features we use to overcome those problems. So I'll be like discussing on a very general way what kind of problems and what kind of opportunities you get in today's data set, in today's world, and how can you leverage on NLP and plus the AI and deep learning technologies that we have to do something cool. Okay. So in this session, I'll not just talk about theories, but I'll also show you some hands-on examples on how we can use leverage on the newer version of Python, which just came, recently it came, and how you can use the natural language process, how you can use the Python 3 version to do cool stuff with natural language processing. Okay. So I'll be showing all those things also. So that's the exciting stuff that I'll be covering in this session, which is showing the newer version of Python with natural language understanding. Okay. The thing which I will not cover, which is more cooler stuff, is the math behind NLP. So it will take some kind of prerequisite and some other stuff which we don't have enough time to cover. So we won't be covering that. Right. But I would try to give you some kind of context behind how things are working. Okay. So before I start with the NLP, something you guys will have to understand that whenever we talk about NLP works on some kind of data, mostly textual data, right? So for example, I'm trying to understand, let's say I have a lot of text. So text could be in any language. Let us assume the language is English for now. Okay. And then I want to do something with that text. One thing is I want to understand what this particular text is saying. That's one application, right? Second application could be I want to find a particular answer out of this text. And there are lots of other things. So this text that we have, mostly these things are known as corpus. Okay. Corpus could be any kind of text, could be labeled or unlabeled, or could be just text, a lot of text, right? So it's just a kind of prerequisite that I'm trying to, a kind of foundation that I'm trying to build here. So whenever you hear something like corpus, it usually means a lot of text, that's all. Okay. So rather than giving you the theoretical definition of what exactly NLP is, what exactly do we mean by natural language processing, let's try to understand natural language processing by looking at some of the applications that we see around. Okay, we all see these applications around, and we'll try to see that how this works and how cool they are. Okay. The first application is the speech recognition, right? So here what happens that you have something in audio, you have something as an audio file, right? And you convert it into a text. So let's say whatever I'm saying, what if you see whatever I'm saying as a subtitle also, and this all those things is happening on the fly. Okay. Similar thing you see on the YouTube caption also, right? Remember? So there is an option. So if a video is being played, you have an option to turn on the caption, which is automatically generated by the YouTube. So it's not manually annotated, rather than YouTube takes the audio on the fly, converts each context or each token into word and displays it, right? So one way of seeing it is the what you see in your mobile, right? For example, Google Home or Siri or Alexa. These uses speech to text, speech recognition and speech to text kind of technology. Whatever you say first, that application, let's say Siri, converts your audio into a text file, a textual language or textual model, right? And then try to make sense out of it. And then whatever the instruction you are trying to give it using your voice, it try to understand that instruction from the text, not just from the audio, but from the text, and try to do something about it, right? So language processing here comes into play, and this is one of the state of the art application that we see around mostly. Second thing that you may have seen is the classification. So one use case here is, when you see your Gmail account, right? There are lots of mail, whatever mailing application you use, either Gmail, Yahoo, or whatever it is. So it automatically finds whether a particular email that came to your inbox, should it be tagged as spam or not, right? You don't have to, I mean, there is a facility to, by that you can manually annotate a particular mail that it is a spam, but usually the mailing system annotates it by itself, so it learns, right? So the way it has been created, it has been trained, and the system has been trained in such a way, whenever it gets a new mail, it looks for some of the features and finds whether this mail is coming from the right person, or is it some kind of hoax, right? For example, there are mails where it says that, okay, I'm calling from Coca-Cola, and you being a very good customer have won some around $5 million. Give me your bank account and we'll transfer the money. Something like that they ask. So your mailing application, whatever you're using, will automatically categorize it into a spam, right? Now, how do you do? So that's the cool stuff, that we have to we have to create the algorithm and process this text in such a way that the machine should be able to classify them automatically. I don't have to tell the machine, okay, when something like this is happening, then you do this, or something like that is happening, then do this. Okay. Is my voice breaking? Am I not clear? If it is breaking, just let me know. If it breaks again, just
No, it's not breaking. It is
clear, right?
clear.
Okay,
Yes.
okay. Then maybe it's your internet connection. Just bear with me. It should be fine. Okay, so yeah. So where was I? So exactly. So the algorithm that you build, it learns on some of the tag data set and tries to classify. Whenever you get a new mail, it classifies it whether it should be taken as a right context or it should go into the spam folder. It does that automatically. So the whole point is we should be able to do everything automatically, right? Okay. Next application that we see around is the sentiment analysis. Now you see, if you guys have been following some kind of social media like Twitter or Facebook or Instagram, or you have mostly in Twitter, right? You have seen that whenever a celebrity like person or a political person tweets something or something happens, people comment there. Now, in this era, it has been a very interesting line of research to categorize people who are against that particular tweet, or who are positively following that tweet, right? So it becomes very interesting to find what kind of tweets those people are posting. Are they are they are they posting negative comments, right? Are they bullying someone, or are they trying to abuse someone, or are they not happy? So that becomes negative kind of sentences or negative kind of tweets. Or are they very positive? Are they supportive of that particular decision or whatever is happening, something like that? So it becomes a positive one, right? So it's very easy, it's very important, especially for political parties, right? And there have been cases where political parties have leveraged on such data to win election, right? So they know for a particular before the election process, what is the mood of the people, right? So let's say on Twitter, I see the data set, okay, and you know that on Twitter there are millions of people who follow. Okay. So based on such kind of data set, I can categorize for a particular political party just based on the tweets that I'm getting, a stream of tweets, how many people are actually positively supporting for a particular party, and how many people are negatively supporting, or they are not very happy with this political party. Just this data, just this analysis gives me how much leverage I have in this election. What are my chances of making people happy in this particular election, right? And people have done this, especially if you see the news of the last election of US, which happened in 2016. You'll understand what exactly happened there. Okay? So the whole point is these kind of data analysis helps us predict very useful things and very critical things. It can help us do very critical analysis also. Okay. And yes, all this is a part of, in a way, is a part of machine learning, deep learning, and artificial intelligence, of course. So whatever I'm saying, whenever you see a use case where a machine has to do something for which it has not seen it yet, it is always a machine learning or AI based technology. Okay, for example, if I'm talking about spam detection, so a new mail is coming, which machine has never seen maybe, but still it is able to classify it whether it is a spam or not. So thus, such kind of application is always based on machine learning. And here machine learning part is we train the machine in such a way that whenever a new data comes, the machine should be able to differentiate. And it's similar to the way we think. Okay, that's why it is known as artificial intelligence. By artificial, it means the intelligence is we try to replicate the human intelligence, right? We try to replicate the human intelligence in machine, but it's not natural, it's artificial. Okay? And one way of understanding this is which I usually use is, let's say you being a person, how do you find whether a particular animal which has just passed around you is a cat or not? Okay, so let's say you're walking down the road and you see a cat. Okay, now you have never seen that cat ever before. I mean, the first time you're seeing that particular cat, still you will be able to recognize, right? Because there are some features of cat which makes it cat for you, your brain. Your brain looks for those features and suddenly it knows that it's a cat. I have not seen it before. I know it's a unique cat. It could be of some unique color, but still I'll be able to say whether it is a cat or not, because I'll know what is the size of its tail, what kind of ear it has, what kind of eyes it has, something like that. Some of the features, brain quickly checks for it and then tells it, okay, this is a cat. So we try to replicate similar thing for machine also. What we do, we tell the machine, okay, these are, so we, for example, we'll give a lot of pictures of cat to the machine and we'll say, okay, mostly the cats look like these. So we'll give various kind of cats picture to the machine and we'll tell the machine to learn those features. Okay, so in a way, we are telling the machine that whenever you see something like this, something like this, it's always a cat. And then whenever a new picture, which we have not fed the machine ever, it comes, the machine looks for similar kind of feature and tells, okay, is it a cat or not? So we are artificially inducing intelligence in the machine, right? And currently, the thing is that machine are able to do some of the tasks in a very good way, but it's not very intelligent yet, right? Still, machine is way beyond reaching the human intelligence level. Although machine can do all this processing very fast as compared to us, but the level of intelligence, level of confidence is way below a human intelligence. So the distraction is I just want to tell you guys that what is the meaning of artificial intelligence. So whatever you see here, the application that I'm trying to tell you is all part of artificial intelligence, or slash, which uses machine learning or deep learning features. Okay. One more thing that you see right now is when it started happening after around 2010, right? So whenever you write a question in Google, it always tells you some answers also related to that question. Plus, it also gives you suggestions of more questions with the answers, right? So this is a question answering feature which Google has introduced. Okay, and this is also a part of natural language processing. Okay, so the whole use case is, given a question, your machine should be able to find the answer for that question. Okay, now there are two ways. Either you give the question with the context also, that okay, this is the question and this is where, this is a whole paragraph and somewhere the answer lies. So find the answer for me in this paragraph related to this question. This is one use case. Second is open-ended. I will just give you the question. I don't have anything to share with you, and no notes, no book, no text, just the question and find me the answer. That becomes an open-ended. Currently, the models that we have in natural language processing is able to handle both the problems, not very accurately, but on a very good level. Right? And we see this in Google especially. Okay. And the third thing is the summarization part. Okay. So summarization is, you have a lot of things, let's say your blog, and you want to summarize it into a few words, or let's say few paragraphs. And the key points in summarization is that whatever you are showing to the, whatever the last part you are showing to the result, it should be mentioning the key points. It's not the case that it only mentions the useless things which are not very important. Okay. Now you may ask that the useful things might change from user to user, right? It could be personalized, right? So the thing is that we train the model in such a way that it takes care of the personalization also, plus it gives a very summarized way of the text that we are providing. One more thing that has become very famous right now is the machine translation. What machine translation is, you give a data in some other language and the machine will translate it into some other language. Okay, and again, this you see in the Google language also, right? In Google. So if you want to write like what is the French of this particular the sentence, it will show the French version of it, and it will show a text box. It will create a text box also where you can write another sentence also, and it will translate it to whatever choice of language you want. Right. So you can do all those things using machine. Right. And here is an example. So as you see here, right, as you see in this particular example, so this is the source data that we have, right, in some other language. Okay, and human has translated this into this, but in English. If human translate this particular sentence into English, this would come. Now, when machine translates into a machine which has been trained into trained one time on a particular data set, that this is the accuracy they achieve. If it has been trained on 10 times on a particular data set, and this is the accuracy it achieves. 100 times it has been trained, this is the accuracy, and 1,000 times it's been trained, this is the accuracy. So you said the number of times you train it, the more data you have, the more accuracy you will get. Okay, so there is that kind of trade-off. So more the data you have to make the machine understand, more will be your accuracy. Okay? So that's why we say right now that data is the gold mine. Okay. And so what are some of the challenges that we face in natural language processing? Okay. And these are not just challenges, these are opportunities also. So people are like doing hardcore research in these challenges and then trying to make state-of-the-art machines which can solve these challenges fluently. Okay. So one challenge, one of the most challenge which you may have seen and you might be asking yourself, right, is the text is a lot superficial. Okay. So if I say something, it might be the case that I mean something else, right? Okay, but we being humans, our brain understand that uh, what implicit behavior of the text, right? Let's take an example. Okay, so again, it's saying that whatever I say, whatever I've written, is just the tip, is just the tip of the iceberg. There is a lot of context which is hidden inside this text. There could be sentiment, there could be tone, there could be the way we talk in different cultures, right? There could be the way we talk in different countries. Okay, everything depends on a lot of parameters are involved, but the text, whatever we are seeing, doesn't show all these parameters. It just shows us the text, and the machine has to understand all these parameters only using the text, right? Which is very difficult task. So let's say if I say uh, uh, and it happens during the messages also, right? When you're talking to someone on messages, sometimes the tone is mismatched. So if you're saying, okay, I won't be available during this time to this time, this could be a very neutral sentence, but sometimes it can be taken as a very rude sentence. Okay, someone might take this as a very rude sentence. Now again, because the context is missing, right? So you don't know what's the context. Maybe the person has said it in a very positive way, but since the context is missing, we can never know the intent of it unless it has been said. Same goes for the machine never understands the context. So see an example here. There's an interviewer, and the interviewer asks the interviewee, please have a seat, right? This might mean that interviewee just take the seat out with him, right? Of course, but if you just translate this English statement, please have a seat, this exactly means that take the seat out with you, isn't it? But we know that this is not what the interviewer means, right? So again, because the context is missing here, right? Similar kind of example, this was very famous once upon a time. So a person posted this on Siri. So the person asked, call me an ambulance. So rather than calling an ambulance, the Siri said, okay, I will call you an ambulance from now. So by that, Siri replaced that person name by ambulance. So whenever Siri asks who is what's my name, Siri will say you are ambulance, because that's what you said. Right. So again, the context is missing. There, the point was that I want you to call an ambulance for me, the literal ambulance. But Siri took it like you want me to call you an ambulance. Again, context is missing. So again, the text data is very ambiguous. You don't know what, if you don't understand it with the context, you can mess up the whole system. The second challenge is language is very, very dynamic, right? By dynamic, I mean the language changes a lot. Okay. For example, nowadays we have a lot of acronyms that we use, especially in tweets or messages or WhatsApp or whatever we are using, even social media, right? For example, these acronym that you see on the left side are not part of English language, but we use it, right? And then the machine has to like understand all these things, right? Or it has to evolve in such a way that it should be able to understand all the language, that the way we have understood, right? So no one told us explicitly, we just understood by taking the data out and going through the messages and talking to people. We understood that okay, these means these things, right? No one explicitly told us. Right? Same way, we have to make the machine understand these acronyms and the dynamic nature of the language, that it should be able to understand the way language is evolving. The challenge here is how to do that. We don't know. And the most important thing is the data is growing by a huge uh, folds, by many folds. So that's one of the challenge in two ways. It's not just a challenge is in NLP, it's also a challenge in data science job. Okay. So there was a survey, okay, which showed that the way data is increasing, is not similar to the way the data scientists are being trained. There is a lot of gaps. Okay, although you see a lot of data science courses, okay, and a lot of people learning those courses, still we have very few data scientists who have the right skill to handle the data. Okay, that's why you see a lot of data scientist job in the market, and it will still grow. And the reason again is because the way data is increasing is huge. You have a lot of just see around you. You have a lot of places, which is all of them are online, and all of them share a lot of data. Right? If you look for TV, we have smart TVs, right? And each smart TV had different OTT platforms, whether it is Netflix, Amazon Prime, or whatever it is, right? They have a lots of data, and currently they are facing a lot of issue to do how to predict something out of that data, right? So that's the problem. Okay, that's one of the challenges. But in context of NLP, the thing is that just the textual data, if we just stick to the textual data, like we see on Wikipedia, Stack Overflow, Quora, those things, Twitter, or Facebook, if we just stick to the textual data only, that's also is increasing by many folds. The web has now several billions of words. If you want to now process all the web pages, it's like even forget the human part, even using the machine, it's kind of impossible. It will take a lot of time, right? So that's the whole idea, that the text is increasing by many folds, and we have to come up with a way so that the challenge is to how to process all the data, how to come up with an algorithm so that we can process all the data and predict things or classify things out of it, right? And that's not only the challenge, the other challenge is that it will keep on increasing, and the acceleration of the slope of increase is also very high. So it is increasing via very higher rate. Okay, so you being a data scientist, what do you need to learn? Okay, so let's say you being a beginner and you want to become a data scientist with specialization in natural language processing. What are the things that you need to understand? What are the skills that a company or an industry, or you being an entrepreneur, what are the skills should be expected from you? The first important thing is, any company, wherever you go, if you want to become a data scientist and you apply for a company, they expect to be a T-shaped person. What is a T-shaped person? So a T-shaped person is someone who not just have the domain knowledge, okay, plus the person should have the broad knowledge also. Okay. So for example, if you go into a company, it's not the case that you will always be working on a particular domain. No, that's not the case. Of course, you being a domain specialist, you will be doing cutting edge implementation and research in a particular domain. Let's say you are in NLP, you work on NLP, natural language processing. Of course, it is expected that you implement like state of the art algorithms and models so that you do the task. Of course, that is expected. Plus, you are also expected to do other tasks. You are expected to take care of the development sometimes. You are expected to take care of the implementation of efficient algorithms, which may or may not include NLP. Yeah, you are expected to understand in general of machine learning and AI. It's not the case that everything which is related to NLP, that's all is expected from you. No, it could be related to computer vision. It could be your company might be making a product which is a combination of NLP and, let's say, audio, video, multimedia, a lot of other things. Okay. So it's not the case that you only work for NLP, other tasks can be taken care of other person. Mostly that's not the case. Okay. So whenever you go to a company, you are expected to have a T-shaped skills, which is you have the broad knowledge also, breadth knowledge also, plus you have the depth also in a particular domain. So just remember this whenever you face an interview. This is something which our interviewer or company looks for in general. Okay. Second thing is, so in a company, where exactly do you fit? what is expected from you, and how do you work with who, what kind of people do you work. So usually the current scenario is like this. So let's say you being an NLP engineer or scientist, it could be an NLP engineer or scientist, right? So what you will be doing, you'll be working as a data scientist in general, right? So there are domain experts who are the stakeholders. So these, depending on the size of the company, these domain experts could be the CEO, which are the stakeholder, or CTO, or these could be research scientists. Okay. And these people are those people who kind of create the product, who create the idea of the product. Okay, what exactly has we have to do and how exactly we have to do. You work with them. Okay, you not just implement the idea, you add on to the idea also. Okay, you give your own idea also, you discuss with them, and then you implement the idea. That's what you will be doing. That's one part. Second thing, you will be working with the development team. So there will be a development team. Let's say your application, whatever you are building, the product you are building could be a web-based product, right? Could be a web-based product, or it could be an app in your mobile, something like that. Whatever it is, there will be a team. There will be a development team who will be working in the back end or front end. And you, whatever things you have implemented, whatever the model, state of the art model, whatever the idea implementation you did, you have to make that implementation get into the back end, right? Get into the back end or get into the app so that your app can query that particular implementation code, okay, and get the desired result. Okay. This is usually a data scientist do in a company, in an industry. They work with the domain expert to create a new idea and implement them. Plus, they work with the development team to how to integrate efficiently your idea, your implementation in the product that you have built. Okay, that's the usual flow. Now, how to become a data scientist? Again, for now, I'm talking about in NLP domain, but in general, how to become a data scientist. The first and the most important thing that we have to understand is a data scientist, irrespective of what domain you choose. It could be NLP, it could be computer vision, it could be some social science related domain also. You could come from a mechanical engineer and you want to work in a manufacturing based company as an AI specialist. Okay, they also require. So every domain requires data scientists now. But you being a data scientist, irrespective of any domain, you should know how to code. That's one of the most important things that is required for anyone. Now, when I talk about code, there are two types of languages which people use. Okay. So there are high level languages and there are low level languages. Low level languages are those which are kind of closer to the machine. Okay. So by closer to the machine, what I mean is, so for a machine, these language, whatever code, whatever implementation you write in these codes, low level languages, it's easier for the machine to understand this code and execute it. Okay. So for machine, it becomes very easy to understand this code, whatever you wrote, and execute it. Okay. But for a programmer, it is kind of difficult to implement. It is kind of difficult to implement. Okay. So it takes a lot of effort from the programmer or uh, uh, you being a data scientist to implement your idea in these languages, but it's very easy for the machine to execute this. Okay. On another note, the high level languages are those languages which are easy to implement from the perspective of programmers or data scientists. However, it takes a lot of effort for the machine to execute. Okay. But current scenario is like this, that we have a lot of resources, and by resources, I mean, we have powerful machines, which are a lot of RAM, right? And CPU power. We have this. So we can live with this, right? That's why currently we have Python-like language or even R, these kind of languages very popular, especially for data scientists, right? And the reason is, again, First, it is easy to implement, right? It is easy to learn and it is easy to implement. Second, it is open source. And by open source, I mean that anyone can use it for profit or non-profit purpose. You can modify code. You can add things on top of it also. You can change the library according to you and release your own version. Okay, you can do all sorts of things, right? And the third most important thing is that data scientists are not those person who spend a lot of time on implementation. No, of course you will be doing these things, but you won't spend a lot of time here. Rather than you will be spending a lot of time on the idea, right? How to solve a particular problem. That's what you have to. That's why you are a scientist, right? You see, that's why you always see a scientist kind of thing associated with the job profile, right? Even if it doesn't say data scientist, it puts a data engineer kind of thing. Still, you will see in the job profile somewhere it will say like you should know the science of it. The reason is that data scientists are supposed to understand how the data is behaving, how the data is behaving, okay? And how I can make the machine learn from it. That's your job, okay? So you'll be spending a lot of time on the idea. You're spending some time on the implementation, but not a lot of time. Given this choice, Python becomes a very good language for data scientists because you don't spend Python is designed in such a way that you don't have to spend a lot of time on implementation because there is a lot of reusable code that you can leverage on. There are a lot of libraries and community is very strong, so you can use those things. Plus, you can spend a lot of time on the idea so that you can come up with a very cutting edge solution. Right? That's why most of the places you'll see that they will ask for Python, right? So let's talk about how we can use Python to understand data science. Okay. So again, why we are using Python? Because Python is extremely simple. It's very easy to understand. And I'll give you an example why I'm saying this. So see this comparison. So on the left side, you see is the implementation of just printing hello world in Java language. So this is Java. You see, you have to write a few lines of code just to print hello world. However, in Python, in a single line of code, you can print a string, right? So it is that simple. Okay, it is that simple, right? So that's why implementing something in Python becomes very easy for any new person. Also, a person who doesn't know programming also can learn Python very easily, and that's what has been happening. Okay. Second important thing that we get that Python has a lot of powerful APIs. Okay. So if you are learning data, if you want to become data scientist or you are in the path of becoming a data scientist, so you will see some of these libraries which I've listed here, and you'll be using these libraries. For example, NumPy is mostly used for statistical analysis. Okay. And scikit-learn is used for machine learning purpose. Pandas are used to format or understand the structured data like Excel, CSV, pickling, those things. Matplotlib is used for visualize data, those things, right? TensorFlow and PyTorch mostly you see in machine learning and deep learning kind of tasks. Now let's talk about what are the current trends. Okay, what kind of job data scientists are doing right now, and what kind of skills companies are expecting from them. Okay, so there was a survey from a very reputed magazine, which is 365, that took the data of around 500 people who are working in Fortune 500 companies. And these 500 people from LinkedIn, and these 500 people were working as a data scientist. Okay. So what they saw that most of the data scientists, so I don't want you guys to focus on other thing, focus on this part. Okay? So most of the data scientists were very comfortable with either R or Python-like language. Okay. So again, this makes us think that most of the data scientists are actually interested in Python. Not just this, even the industry is interested in Python and R-like language, right? Okay. And the second important thing that they saw was not all the data scientists that are working were actually data scientists before. Specifically, they saw that people who are working as a data scientist, 2 jobs before, most of them, for example, 25% here, 9% here, and 19% here. Okay, these people were not data scientists. They were actually from different domains. They didn't even know computer science, to be honest, right? Very few of them were from data science or IT domain. Right. This is again a very special, important behavior that people from different domains are also coming into data science, and they are doing a very good job because these people who they surveyed were working in Fortune 500 companies as data scientists. So people from various domains like humanities, social science are also coming, mechanical, civil, pure sciences. They're also coming inside the data science job, and they're doing very good there also. Okay. Okay. One more interesting thing that they saw, and it's a current trend also, that the most of the data scientists they saw had some kind of extra skills that they showed in their LinkedIn profile. Either they were doing some kind of very good courses, or they had some kind of cert already. They have completed some kind of online course, which makes them a good data scientist. So this trend tells us that it not just tells us that people are looking for such kind of courses. It also tells us that it gives company a kind of authentication, right? That these people are actually good because they have done such kind of courses. So people in general, they have seen that 40% of the people had attached some kind of online course related to data science. Okay, so this is again one of the important facts. Okay. And what kind of job the data scientists are doing? So in India, and this is like 2016 data. Okay, so this trend has also changed. But in India at that time, the trend was that most of the people were into 68% especially were working in the financial sector or technology sector, right? But the trend changes in US. If you see, most of the people are actually working in industry. I mean, these are just data scientists. So everything what I'm talking about in the data scientist trend. So industries right now are taking a lot of data scientists. So industry who are making some industrial projects, right? For example, they could be making rockets, they could be making ships, they could be making some other stuff. And they are requiring data scientists to do some cutting edge research and implement those things so that they can get more profit, something like that, right? So the point is that even in industrial experience, people are requiring data scientists. Or you can see it like this, that at in every domain, people are requiring data scientist type people. So the jobs are going to, there will be a lot of jobs in future. It's not like there is no saturation point at this point. Okay, so you being a data scientist, and we have been talking about this machine learning and deep learning. So what is the key difference between these two? And you may have heard many kind of definition between these two, right? What exactly is the key difference? So the key difference here is that in machine learning, what happens that you want the machine to learn something, and you specifically tell the machine what exactly it should learn. For example, let's take our cat example. Okay, so let's say I want the machine to learn that whenever a new animal picture I give it, right, it should be able to tell whether that picture is of cat or not. Okay, a simple task, right? So what I will do to make the machine understand this fact, what I'll do, I'll create a lot of pictures of cat, or I'll just accumulate a lot of pictures of cat, of different types of cat, and I'll tell the machine what exactly you have to look inside this picture. So for example, I'll tell, look for the eyes, okay, look for the ears, okay, look for the fur, look for the tail. So I'll give some parameters that look for these specific parameters. Let's say eyes, tail, ears, fur, maybe mouth, okay, and learn those features. Okay, so whenever you see picture, take out these things and learn this. Okay, so whenever I give you a new picture, okay, of an animal, you again see all these things, for example, eyes, face, ear, okay, tail, and other thing, and try whatever you have learned from this data, try to classify based on these features only. So the whole point is, whatever input is given, me being a data scientist will extract the feature or tell the feature, and will tell the machine to use this feature to understand whether a particular thing is there or not. It could be a prediction task, or it could be a simple classification task. That becomes a machine learning engine. In deep learning, the scenario changes by a lot. So in deep learning, what happens, what I will give, so what I will do, I will give the machine on, for example, in our cat instance, I'll just give machine a lots of cat images. Okay, I'll tell that this is cat. Look at this image, and this is chess. These are the cats. Okay, I'll just tell the machine that these are cats. I will not tell the machine what exactly you have to learn from these cats. Okay, so I'll let the machine decide what it wants to learn, right? And then whenever a new picture comes, the machine should be able to classify whether it is a cat or not. That's all. So here in deep learning, future extraction, or the parameters that we try the machine to learn, is extracted and learned from the machine automatically. The user doesn't give them to the machine. So machine learns everything automatically. How it learns, it's still a research question. What it does, that we know, but how it does, we don't know. Okay, we have some idea, but it's again kind of very abstract way. But the whole idea is, we don't tell what exactly you have to learn. We just tell that what you have to learn. So we tell that, okay, these are the images, and you just have to learn that whether these are cats or not. Okay, and whenever I give a new animal image, you just have to tell me whether it is a cat or not. Okay, so deep learning, we don't give the features, what exactly the features you have to learn, rather than we just tell them you have to, whether you have to, you just have this data, learn from it. Whatever you want to learn, it's up to you, but in the end, give me this output. Okay, so that's the whole idea behind machine learning and deep learning. Okay, now I'll get into the hands-on part. Okay, and I'll start talking about what are the things that we use in so essentially, I'll go to the Python 3, and I'll try to introduce what are the new features that are included in Python 3, which you can use to process natural language, or you can do natural language processing using Python 3. And it's kind of very easy. Even you can do if you know a little bit of programming, right? So this feature came very recently, and people have started using it, still in beta mode, but people have started using it. So one thing you can do is, if you want to learn about it, just Google for Python NLU. Okay, just Google this, and you'll see this link, NLU Johnson's lab. Okay, so this is the John Snow labs. Okay, and here you'll see this state-of-the-art text mining Python. Okay, so you can go to the documentation and see what are the things required for you to install and how we can use it, right? So for example, I'll show some of the features. Okay, and I'll be using Google Colab. So I am on Colab, for example. Here you can see, right? And I'll show you some of the applications. Some of them we have discussed, some of them we have not discussed, but I'll show some of the application and how easy it is to implement this in Python 3 using the NLU library. Okay, so to start with, I've already installed this library here. Let me run it again. Okay, and then it will install all the new packages, all the new packages that are required for me to use this particular library and do the natural language processing in Python. Before this, to do everything in Python, I had to leverage on different libraries. Okay, and I had to do some other kind of pre-processing So there was a lot of stuff involved, but now it becomes very easy because everything is integrated in Python only. You don't have to do a lot of stuff, rather than you can just get into your into the hands-on implementation by just downloading this library, and you can work on it, right? So if you guys are interested right now only, you can just go to this page. Okay, just read the documentation. So it's very easy. Just go to the usage and you'll see some of the examples and some of the application, right, which you can directly work on. Okay. The only thing that you want here is that it should be the newer version of Python, which is currently we are at Python 3.10. So maybe you can install that version in your machine, whatever you are using. And once you have installed the newer version, you can just go to this part and go to the installation. And here you'll see how to install it in various operating systems. So let's say if you are working on Windows, then you can just go to this part, and here you'll see that how to install Windows packages. Okay. So I have already installed it. So to check this, I'll just write here to see whether my thing is working. So I'll just import this library, which is NLU, right? And I'll just do a simple task. So NLU dot load emotion. Okay. And then see, I want to predict the emotion of or the sentiment of a particular sentence. For example, wow, that was easy. So here, what the task that I want to do is, I want to predict what kind of emotion this particular sentence has, which is, wow, that was easy. So let me just run it. And it will take a few time in Google Colab, okay, because I'm running it in internet. And it will just show the emotion for this particular sentence. So let me, till it runs, let me just paste this to the chat so that you guys can also look into it and read the documentation at that point. Let me know if you guys got the link. Okay. Okay, and I'll give you the link for Python 3 also. So the version that you have to install here is, if you're looking at it, is the, let's go to all the releases and this one. Just go to the download part. So let me give this part also the link. Here you can see the latest version of Python. So that currently the latest version is 3.10.5. So let's download this. Just make sure that it works in your system. Okay, don't worry if you don't know that particular thing. But yeah. So see this here. So here you can see that I ran this particular sentence. Why that was easy. So this is the sentence, and here you see the confidence, right? So here you can see the confidence. So confidence, it says 0.99. So the confidence will come in terms of from -1 to 1. So closer to 1 means it is positive. Closer to -1 means it is negative. Okay, so you can see the confidence that I'm getting is 0.99, which says that the statement that I've just written here is a very positive sentence, right? So that's what it's doing. So it was a very simplistic example just to show whether it is working or not. So let's see some of the application of natural language processing using Python 3. And currently we are using the NLU library. Okay, so NLU library was recently introduced. Okay, and it is now being part of Python 3 also. Okay. So we'll be using that. So let's see some of the application. So here you can see I've imported that NLU library. You don't have to worry about it right now, right? Just Just see the stuff that we can do. Now we'll be using a model, a deep learning model, which is known as T5. So this T5 is a transformer model. A transformer, okay, which was introduced by Google. Okay. So again, don't worry about what exactly is transformer. So it's a deep learning model, okay, which has been learned on various data sets, various kind of data sets, a lot of data, okay, and it can do a lot of tasks, right? It can predict next word, okay. It can find the sentiment of a sentence, okay, and do a lot of stuff. So let's try to see all those stuff, some of those stuffs using the T5. So let's try to see the first task. So the first task that I will be doing is the grammar check. So let's say I have a sentence. Which is, let's say my name may. Okay, so I have written some random sentence which is grammatically incorrect. Now for a human, it is very easy to know. Right? For us, it is very easy to know that this sentence looks grammatically incorrect for English language, right? But for a machine, it's not very easy. How will you tell a machine to know whether this particular sentence is grammatically correct or not? Let's take another sentence which is grammatically sound. So let's take something like this. My name is Amit. Okay, so this is grammatically sound. So I'll be using, so let's use the transformer model. This is T5 transformer. And let me set the task to sentence. So this task is known as COLA. Okay. COLA sentence. Okay. So my data is these two sentences, which is sentence 1 and sentence 2. Okay. And let's predict whether these two are grammatically sound or not. Okay. If I predict the data here using the T5, let's run this. Okay, so now I'm running this task. So my data has been created here. Okay, so currently I'm running this particular code. So my data has been created here. So my data contains these two sentences. The first sentence is this, sentence 1, and the second sentence is sentence 2. Right? Right? Okay. And the thing that I want to do here is I want to predict the whether these two documents are grammatically correct or not. Correct or not. Right? So let's see that. Let's see the base here. Let's wait for a few seconds. Give me the so here what I'm doing is I'm using the GPU model of Google Colab. So the GPU model in Google Colab, if you go, you can use free GPU. So if you see on the top right, okay, you can see that this amount of RAM and this amount of disk has been provided to me. I can freely use this thing. Plus, I can get the GPU. So whatever deep learning models we want to learn, it's better to run them on GPU, okay, rather than on CPU, because on CPU it takes a lot of time. Right? So GPUs are designed in such a way that it can be able to do the task in very small amount of time. So prediction and those things are very easy, right? So here you see that the result that I'm getting is for the first one, the first document. See where it's written, my is name Amit. It said it's unacceptable, which means that it's saying that it's grammatically incorrect. Whereas the second sentence, which says my name is Amit, it says acceptable. So it's a binary classification task. So this is a classification task, right? What we are doing, we are trying to classify. We are trying to classify whether a particular sentence is grammatically correct or not. Right. Now, again, for a human being, it's very easy to know, right? But there could be many possibilities of incorrect statement, and there could be many possibilities of correct statement also. Now, how to make machine learn about this, right? So I'm not talking about how this transformer was learned to make this prediction, but we are just looking at the applications of these things. So using this transformer model or deep learning model, which was provided by Google, we can do this such tasks. Let's see another application. So another application that we'll be looking for is three-class contradiction. So the task 2 we have is three-class contradiction prediction. So what exactly what I'm trying to do here. So let me just first set the task here. P5 transformer. And here I'll set the task to multi. So see what is three-class contradiction is. So I will have a hypothesis, and then based on hypothesis, I'll make some statement. So that will be my premise. And the model should be able to tell whether that particular premise is correct or not. So let's take an example. Let's say my data is like this. So let's say my data is something like this. I have a hypothesis which says that Delhi is the capital of India. Right? This is my hypothesis, which is also a fact. Okay, but currently just take it as a hypothesis. The premise is what I will say, what the statement that I'll make based on this hypothesis is, let's say, Kolkata is the capital of India. Now it's clear that whatever the hypothesis I made, the premise is definitely not correct. So this, I'm giving a very simplistic example here, which I'm saying Delhi is the capital of India, and then my premise is based on this fact, I'm saying that Kolkata is the capital of India. So based on whatever data I've given, this statement, whatever the premise, Kolkata is the capital of India, is not correct. Okay? The whole idea is based on the hypothesis. The model should be able to understand whether the premise that the person is trying to make, is it correct or not. That's known as three-way contradiction prediction. So let's say predict this. So T5.predict, and I'll predict the data. Right? So let's run this. Okay. So here you can make any kind of hypothesis. You can have your own hypothesis. Okay. You can have your own story here, a story somewhere, right? Where, for example, you can take the whole Harry Potter story inside the data. Okay. And then you can ask a question based on this data that you have provided. And the model will be able to predict whether that particular question or a particular premise that you are making, is it correct or not. For example, you see here, whatever I make, my premise, the model is saying that whatever premise you made is a contradiction. Not correct. You're contradicting the fact. The fact is Delhi is the capital of India. You're contradicting it by saying that actually Kolkata is the capital of India. Right. So the T5 model is very good at doing three-way classification. Okay. Okay. Let's make another. Let's do another task. So task C. Okay. And see, everything I'm doing is like using the NLU library. I have not used anything else, just Python and NLU library. Let's do question answer. Question answer classification. Okay. So here I'll just copy this and set the task to question answer classification. So here, rather than MNLI, this would be QNLI. Okay. So let's define a data here as, so let me just copy this and I'll redesign the data. So here, what I'll put is that my question is, let me first write the text or context here. So my sentence here is something like this. Venus, also known as the morning star, is the second planet in the solar system. Right? This is the fact that I've stated here. Now my question here is, what is morning star? Okay. So this I'm taking a very simplistic example here. Okay. So this will not tell me the answer to this question. We can do that also, but I'll not show that as of now. This will only tell whether you can find the answer to this question in this particular sentence or not. Okay. So is it an entailment of this question? Entailment of this question is present in this particular sentence or not? That's the task we'll be doing. So if I predict this, t5.predict the data, and if you see this, so here it will not tell me the answer. It will just say that whether I can find the answer to this question inside this particular data, whatever have been provided or not. Right. So it says here that the question that you are asking actually is an entailment, which means that the answer is present inside this sentence only. Okay. So this is a very preliminary analysis that you can do to find whether a particular answer to a question is present at a particular place or not. Okay. In a context way, it's not doing a string matching here. Right. In a contextual way, it is checking whether that particular answer is present or not. That's the whole point. Okay. Let's see one more task. Okay. So let's try to see the open-ended question. So the task I have here is open-ended question. Okay. So open-ended question answering is, I just ask a question to the model. Okay. And without any context, it should be able to provide me the answer. Right. So if I just do, let's say NL, so P5 dot predict, P5 dot predict, and inside this, I'll just ask, who is the president of India? Again, it's a very open-ended question, right? So I'm just asking, who is the president of India here? Nothing else. So it's based on QNL. Let me just change the task here quickly. So NLU NLU dot load there file. Now let me just it was just saved to the previous thing. So let me just get the T5 version. Right. Unfortunately, it says Rajendra Prasad. Okay. This is not what I expected, but nice. It should be saying. So previously when I ran this, it was showing Ramnath Kovind. Mess. So I don't know why it messed up. Okay, let's check who is the president of that's new. So let's say who is the president of USA. Let's see what happens. That's weird, but close. Okay. So it is Donald Trump. So it should be saying the new Biden. But yeah, so the thing is that we are asking very open. Let's ask some fact. So it becomes a very current affair question. Let's ask so what is the capital of Australia? Let's see this. This task it does very good. So let's ask one more question. How many states are there in USA? Let's try that. That's good. Someone said maybe the year has to be provided. Let's do that. Is Google GPU free or charge? Yeah, Google GPU is free, so you can take the free version also. The only thing here is that the free version doesn't give you a lot of time. So I mean, it gives you a very specific amount of time, and you can work around it. And after that, it gets allotted to some other person. Okay, so you get it on a round robin manner. Okay, but you can, if you want it to be present for you for a longer time, you can subscribe to a pro version, which will take some money, and there you can get a dedicated memory. But for us, if you want to just see something and try to experiment on something, the free version is more than enough, right? So okay, since we have a very less time, I'll just stop here, okay, and open for the questions. If you guys have any questions, just let me know and I'll try to answer them. So any questions if you guys have? Just do that. Let me just ask that question. Using the current president of India. So let's try this. Oh, it works. Nice. So yeah, some kind of context was missing, I guess. So if I ask who is the current president of India, it says Ramnath Kovind. Right. So again, my point is that see how simple it is to do these kind of tasks, right? You don't have to spend a lot of time. I didn't spend a lot of time. I did everything in front of you, right?